Most people treat money and coding as two separate worlds. We don't. We use the Double Helix method. We use financial theory to understand what to do, and we use Python code to verify that we are doing it right. In Lesson 1, we put on our armor. We learned to be guardians of our money. We calculated our net worth, isolated toxic debt, and secured our solvency. That was the defense. Please, go and watch that video to catch up. In the project for Lesson 1, we translated the philosophy of Lesson 1 into data frames on Python. We didn't just guess our status, we proved it, with data coming from Excel sheets. You now have a script that takes raw Excel files and generates a financial health report. We learned how to start using Pandas, the most powerful data analytics Python library. We calculated how much your emergency fund should be to be prepared before you start investing. But today we switch to the offense, or rather, to expansion. Today we are going to answer the million-dollar question. Okay, my savings are in order. Now what do I buy? Today we will deep dive into passive investing and ETF composition. Why are ETFs the best place for most people to start? And we will cover these concepts by learning a new Python tool, lists, and methods on lists. Be ready. The gurus in the financial industry will tell you that you need to find the needle in the haystack. That secret stock, that cryptocurrency that will explode tomorrow. But we don't play guessing games. We play with mathematics. And math says something surprising. Don't look for the needle. Buy the whole haystack. The entire personal finance industry is built on a myth that a smart guy in a suit can pick the winning stocks better than you can. They call this active management. We reject this, not because we are rebels, but because we can count. The data is irrefutable. According to the SPIVA scorecards, the actuarial tables of investing, over a 25-year period, approximately 90% of active fund managers failed to beat the S&P 500. Think about that. These are professionals with Bloomberg terminals and armies of analysts. And they lose to a simple market average 9 times out of 10. If the pros can't find the needle in the haystack, why should we try? The solution: don't look for the needle, buy the haystack. Today, we're going to understand the perfect vehicle for doing this, ETFs. We'll see how they work, why economic cycles shouldn't scare you, and most importantly, how we model these financial giants using Python lists. Let's dive in. Now, how do we invest in this without going crazy analyzing thousands of companies? Enter our two protagonists, the index and the ETF. Think of it this way. An index is the recipe. It's a theoretical list that says, to represent the US economy, we need a bit of Apple, a bit of Microsoft, a bit of Amazon. It's just data, a market thermometer. But you can't buy a recipe. This is where the ETF, Exchange Traded Fund, comes in. Imagine you want to buy gummy bears. Active management, trying to beat the market, would be trying to pick only the red gummy bears that you think are the tastiest, one by one. It's slow, expensive, and you might be wrong. The ETF is buying the variety pack. It is a vehicle, a bag that already contains all the gummy bears on the list from the index. By buying just one share of an ETF, you automatically own a tiny piece of hundreds or thousands of the best companies in the world. In financial terms, this bag is an ETF. Like the S&P 500, it's a basket of the 500 largest, most profitable companies in America. The S&P 500 isn't a static list, it's an algorithm. If a company starts losing money, it gets kicked out, like Kodak or US Steel. If a new company dominates, like Tesla or Nvidia, it gets added. Your job? You don't need to pick the winners. The index automatically holds more of the winners and less of the losers. You are surfing the momentum of the entire economy. We have all the theory ready. It is time to open Colab or your favorite Python editor. If you are new to programming, I really recommend you watch the first video. We explore what variables are and how to use the basics of Python and Colab. For this video, I will skip the intro and go directly to the next step. Okay, we know what to buy. Now, How do we represent them in Python? To a financial engineer, an ETF is nothing more than a list. A list is one of the most powerful tools in Python. It's an ordered collection of items. Before we can manipulate complex financial datasets, we must understand the atomic unit of ordered data in Python, the list. If a variable is a single data point, like a number or a string, a list is a sequence. It is the computational equivalent of a row in a ledger or a column in a spreadsheet, but with significantly more flexibility and power. A list in Python is an ordered collection of items, defined by enclosing elements within square brackets and separating them with commas. A Python list is heterogeneous, meaning it can contain mixed data types. You can store integers, floats, decimals, strings, text, booleans, true, false, and even other lists within a single list structure. Let's review some examples. Example 1. We can have an integer list called numList, which is a simple list of integers representing market price data. For example, 345, 245, 543, 356, 104. Example 2. We can also have a string list called stock list, which is a simple list of strings representing market company long names. For example, Apple, Amazon, Tesla, Nvidia. Example 3. Finally, we can also have a mixed list called mixed_list, which is a list that can have anything inside: values, strings, and even other lists. This kind of list is less used, but it's good for you to know that we can create lists of lists. When we verify the type of this variable using the Colab Variable Explorer, you can see the system confirms it is of type list. It also tells you the shape or size of your data. If a list contains 5 elements, its length is 5. You can also see the values right there on the Variable Explorer. Let's start with the S&P 500. This is the gold standard. It represents the 500 largest companies in the United States. But be careful, it's not a static list. It is a self-cleaning mechanism. To get in here, a company has to be profitable and giant. If a company stops making money, it's out. It leaves the index, and a new, better one enters. Let's look at the top 20 of the 500 giants through the lens of code. For this, I will ask Gemini, or another AI, to give me a Python list of the first 20 tickers on the S&P 500 and assign it to my list called SP500 tickers. I am doing this to make sure I have the latest updated information. I also want to have the biggest companies first. For that, it is important to understand that companies are organized by market capitalization weights. Market capitalization weighting means that the larger a company is in total value, the more influence it has on the S&P 500's price. Massive companies like Apple or Microsoft are the heavy lifters, whose stock price changes move the index much more than smaller companies. We will dive deep into this concept in the project for this lesson in our next video. If you don't want to miss it, please subscribe to the channel and like this video. Now, let's copy-paste the list into the Python console. Here is the golden rule of Python. Counting starts at 0. If we want to see the first company in the S&P 500, the biggest one, we don't ask for number 1. We ask for index 0. We just need to call the list and write 0 inside the brackets. SP500 tickers 0. For the second position, we use the number 1. For the third position, we use the number 2, and so on. The last element of this list has the position 19, since this is a list with 20 elements. Attempting to access an index that does not exist, for example, trying to access index 20 in a list of 20 items, will result in an error. This is the system's way of preventing you from reading memory that hasn't been allocated to your data structure. Conversely, Python allows negative indexing, where -1 refers to the last item in the list, -2 the second to last, and so on. This is particularly useful in financial time series, where the most recent data, the end of the list, is often the most relevant. We will dive deeper into this later on. Analyzing the data often requires analyzing a specific window of data, a slice. Slicing allows us to create a new list from a subset of an existing list. The syntax for slicing is list start, stop, step. The mastery of slicing is essential for handling time series data. Start. This is the index where the slice begins. Stop. This is the index where the slice ends. This is a crucial distinction. The slice stops before reaching this index. Step. This is the interval between elements. Default is 1. This is the jump in counting the elements. This is the operational logic of slicing. SP 500 tickers 3, 10, 1. Starts at index 3, ends before 10, and takes all the elements. SP 500 tickers 1, 8, 2. Starts at index 1, ends before 8, but only takes every second element. This allows for sampling data, or skipping rows. Now, let's look at the shortcuts. SP 500 tickers 2, 5. Starts at index 2, takes index 3, and takes index 4. It stops before index 5. SP 500 tickers 4. If the start is omitted, it defaults to 0. This grabs everything from the beginning, up to but not including index 4. SP 500 tickers 2. If the stop is omitted, it defaults to the end of the list. This grabs everything from index 2 to the absolute end. Let's review some other ETFs. If the S&P 500 is the general economy, the Nasdaq 100 is the turbo engine. It focuses on the 100 largest companies on the Nasdaq exchange. This is where the tech giants live. Apple, Nvidia, Microsoft, Google. It is more volatile. It moves more sharply in recessions. But historically, it has had explosive growth, thanks to the technological revolution. And what if we don't want to bet only on the United States? That's what the MSCI World is for. Despite its name, it focuses on 23 developed countries. You have the US, but also Japan, the UK, France, Germany. It is the ultimate geographic diversification. If one economy falls, you have the others to compensate. It covers 85% of the entire free investment opportunity in the world. We realize that the giants of the financial world, ETFs like the S&P 500 and Nasdaq, are not magic. They are simply lists. But a static list is dead data. The market creates new price data every single day. Companies merge, tickers change, and sometimes we make data entry errors that need fixing. We don't just need to store data, we need to manipulate it. In Python, we use methods. Think of these as the verbs of programming. If a list is the noun, the object, the method is the action you perform on it. Methods allow us to construct datasets dynamically. They let us simulate the passage of time, clean up our mistakes, and analyze our risk. We are going to look at the essential toolkit you will use. We are going to apply verbs to the lists. Financial history is written one day at a time. When a new month ends, we don't rewrite history, we add to it. We use .append. This adds a single element to the absolute end of the list. It's how we build a transaction log, adding your monthly savings one by one. Sometimes, a simulation fails. You want to wipe the slate clean and start a new test without deleting the variable itself. For that, we use .clear. It removes all items, leaving the list empty, effectively resetting your data buffer. Once we have data, we analyze frequency. How many times did the market crash? How many times did we hit our profit target? We use .count. This returns the number of times a specific value appears. It is your basic frequency analysis tool, perfect for asking, how many shares of Apple stock did I buy this year? But before we start manipulating this data, we must be guardians. We never risk our original raw data. We use copy. This creates a duplicate of your list. We experiment on the copy, leaving the original safe. Now, we clean. What if we imported a bad data point? Maybe a bankrupt company like Enron is cluttering our portfolio. We use remove. This searches for the first occurrence of that specific value and deletes it. It is value-based cleaning. But what if we missed a spot? Maybe we forgot to record the dividend from January, and now it's March. We need precision. We use insert. This allows us to inject an item at a specific index position, shifting everything else to the right. It's perfect for fixing gaps in a time series. Finally, we change our perspective. Sometimes, chronological order is boring. We want to see the most recent news first. We use reverse. This flips the order of elements in place. It transforms a chronological timeline into an anti-chronological one, putting the newest data at index 0. And lastly, we need to find the needle in the haystack. If you need to know exactly where a specific price occurred in your history, the coordinates of the event, you use .index. This returns the index of the first item with that value, telling you exactly where that data point is located within the structure. Build, clean, analyze, locate. These are the verbs of the Quantified Self-Financier. Let's open our environment and put them to work. Now, we also have a new list with the top 20 of NASDAQ companies. First, let's assume that a new company, JP Morgan, enters the S&P 500 index. We need to add this new company to our list. For that, we use Append. We need to call the list and write .append after it with the name as a string inside the parentheses. Now, JPM is added to the very end of the list. Let's try our next method. Clear. This removes all items from the list, leaving it empty. This is useful for resetting a buffer or a temporary calculation list without deleting the variable itself. Before that, we can create a temporary list with the top stocks by slicing the S&P 500 full list. I can clear that list, and it will be an empty list that I can update whenever the top 5 of the S&P 500 composition changes. Our next method is count. This returns the number of times a specific value appears in the list. Let's say that we accidentally added NVIDIA twice to our NASDAQ list. We can use count to check for duplicates or to count how often an event occurred. Let's do something more interesting. What if I want to concatenate the top 10 stocks of the S&P 500 and the NASDAQ? I can use count to check how many times any stock appears in the top of both lists at the same time. For example, I can check for Tesla, Amazon, whatever stock I want. The next method is copy. It's simple, but this is essential for data safety. It creates a shallow copy of the list. We use this to experiment on a dataset without risking the original raw data. Let's start by creating a backup of the S&P 500 before we start deleting things. We can use the remove method on the backup list. Remember that this method searches for the first occurrence of a specific value and deletes it. It is value-based, perfect for removing specific items like a delisted company. Let's play with this method. We can remove NVIDIA, Apple, Microsoft, Amazon, Google. As you can see, I am deleting all those tickers from the main list every time I run the cell. Let's use the insert method. It allows for precision placement. It injects an item at a specific index, shifting all subsequent elements to the right. Remember that in a list, the first index is 0. For example, we can reinsert Meta at position 4, or reinsert NVIDIA at position 1. The method reverse simply reverses the order of elements in place. This is useful for flipping chronological data, oldest to newest, into anti-chronological data, newest to oldest. The last item is now first, and the first item is now last. What if we need to find a company in a big list? For that, we can use the index method. It returns the index position of the first item whose value is Netflix, for example. This helps us locate exactly where a data point is within the structure. There are a lot of methods in Python for lists. Two of the most common ones are len and sort. You can check the length of a list by applying the len method. You can also sort alphabetically using the sort method. I invite you to recreate the lists of the S&P 500 and NASDAQ and play with them. That's the best way to learn. In the next video, the project for this lesson, we are going to apply some of these methods to lists created from columns of a data frame. We will dive deep into the analysis of the S&P 500 and NASDAQ using Python lists and methods. ETFs are not just financial instruments. They are engineering tools for your wealth. And now, you know they are also just lists waiting to be analyzed. In the Quantified Self-Financier universe, we don't blindly trust what gurus tell us. We trust the data. Lesson 2 begins by contrasting the defensive strategies we covered in Lesson 1, like calculating net worth and securing solvency, with the offensive or expansion strategies introduced here. It emphasizes the Double Helix method, combining financial theory with Python coding to verify our decisions. The key question is, what should one buy after securing savings? We reject the myth of active management and stock picking. Instead, we advocate for buying the entire market haystack via ETFs. Supported by data showing that 90% of active fund managers fail to beat the S&P 500 over 25 years. We explained that an index is a conceptual recipe representing a market segment, but you cannot buy an index directly. ETFs, exchange-traded funds, are the practical vehicles that embody these indices. They allow investors to buy a basket of stocks in one single share. This simplifies investing, avoids the pitfalls of active management, and provides automatic exposure to market winners based on algorithmic selection. Then, we transition to practical Python coding, introducing lists as the fundamental data structure to represent these ETFs. Lists can hold ordered collections of data, whether it's integers for prices, strings for tickers, or mixed lists. We introduced list methods as the verbs to manipulate this financial data. These allow us to build transaction logs, clean data, and locate specific data points. In the next video, the project for Lesson 2, we are going to open our Python environment for real. We will download the S&P 500 data and load it into a list made of columns from data frames. See you in the code. If you found value in this approach, please hit that like button, because it tells the algorithm to share this truth with other future investors like you. And if you got stuck on any line of code, drop your error in the comments below. I actually read them and I'll help you debug. We are in this together. Now, make sure to subscribe. Carry this momentum forward. I will see you in the next lesson.